Okay, so
recording in progress.
There we go. Okay, so you're going to see a combination of questions. So remember, we covered 3 units. We covered linear regression, we covered two-way tables, and we covered sampling. This is a problem on linear regression. So here they're asking you to explain the meaning of 60 and -30 in the context of this problem for the equation that's given to you. Now remember, x represents the diameter of the tree. Y represents the volume of timber that you actually get from the tree. So obviously, if you have a wider tree, you can get more wood, right? That just kind of makes sense, right? And apparently you have this formula here that gives you that. And the way this formula is probably created is they probably sampled maybe 100 trees, measured the diameters, and probably cut the trees down and figure how much timber they can get from that, right? And then they had all the data. They ran to some sort of program, either in Excel or you can use a calculator if you want to, and spits out an equation. There's actually a formula you can use to compute the slope and the y-intercept using standard deviations, but that's just not terribly efficient, right? Just throw into a program, the program spits out the equation for you. But we want to understand what it means. So 60 is our slope, right? Remember, slope is a change in y or a change in x. Now, what does y represent? Y represents the volume. So it's a change in volume. What does x represent? X represents the change in diameter. And the value, of course, is 60. So what this means is that there's 60 cubic feet for every 1 foot of diameter. So if you think about it, 60 is a fraction, 60 over 1, whereas 60 is the volume and 1 is diameter. So for every time the tree gets a foot wider, so every time the diameter increases by 1, you gain 60 cubic feet of volume. So the way you could probably write it is as a text box. Again, I'll put this in Schoology as well, the solution key. For each 1 foot increase in diameter, volume of timber increases by 60 cubic feet.
That's how I interpret it. I want to think of it as a ratio, right? It's a ratio. So for every time this goes up by 1, this goes up by 60, because 60 is 60 over 1. That's positive, right?
And I spelled volume wrong, but don't worry about it. So the -30 is a little strange. The -30 is mean y-intercept. Remember, the y-intercept is the y value when x equals 0. Okay, when x equals 0, fine. So that means that if the tree, let me actually use a text box. And so what is my y value? Of course, it's -30, right? So what does this mean in the context of the problem? It means that when the tree diameter is 0 feet, the volume of timber is -30 cubic feet. Clearly, this makes no physical sense. How can this make no physical sense? There's 2 reasons why. Can it go, Luke? How do you have value of volume? Right, that's weird. And also, how can the tree diameter be 0? If the tree diameter is 0, you have a tree. You have a tree, right? So it's weird. So sometimes you have to take this with a grain of salt. Sometimes we don't consider linear regression models until a certain x value. So sometimes we restrict the domain. Like maybe we'll start looking at when x is like 3, or sorry, when x is like half. So when x is half, then y is 0. So
Or maybe when x is
like 1. Sometimes you have to kind of like figure out what domain does this make sense. So yeah, so that's how you interpret it. Now this one's easy. That's just 0.1.5, right? That's just easy peasy. -30. That's a free point. You should not miss those. So that's -30 plus 90. That's 60. And cubic feet, you can put feet cubed. So the expectation is that if you go outside and measure a tree and it's 1.5 feet in diameter, great. You're going to get about 60 cubic feet of wood. Awesome. Now, the correlation coefficient -0.913. Remember, this is asking us how X and Y are correlated. So why is this a typo? Because R should be positive. Why should R be positive, not negative? Right, exactly. We expect volume and tree diameter to change in the same direction. They should change in the same direction because we have a positive slope. We have a positive slope, we have a positive correlation coefficient, just so you know, and likewise negative. So that's the reason why. Okay, so hopefully we're okay at that. Perfect. Okay, let me show you how to go about the next one. One sec here. Okay, so and one sec here. Let me pause really quickly.
Recording.
Okay, so let's look at number 3. So the number of adults, Americans, who smoke continues to drop. Here are the estimates of the percent of adults aged 18 and over who were smokers in the years between 1965 and 2006. Okay. So find the least squares regression line for predicting percent of smokers from year. Let's do regression line using the correct notation. Okay. So what I probably will do, just because it just might seem a little off by using 1965, I'll let X. It's up to you, actually. I don't really care if you let X equal the actual year. But sometimes it's good to let X equal the number of years since a certain year. So let X equal the number of years since 1965. That way, the y-intercept kind of makes more sense for us. So I'll be 0. And that would be 9, 14, 18, 22, 25, 28, 32, 35, 37, and 43. No, 41. There you go. So I'll probably just do that. And so to find the least squares regression line, again, here's what you do. So you go to TI Smart View, you go right here. It's taking a sweet little time. Okay. I'll go ahead and clear. So remember what you do is you have to go to stat and edit. Yep, I definitely see that from the other data. Yep. Okay. So I'm going to clear these. Okay. So I'm going to type in 0. And then remember I did said 9, Actually, that might make it easier. 14, 18, 22, 25, 28, 32, 35, 37, and 41. Then I go to the next column, 41.9, 37, 33.3. I know it's very boring, but this is what you got to do. Make sure you have a calculator on Thursday. I'll have some extra ones, but I'm going to have enough for everybody. 28.6, and it's a little static. Let me turn that down. 20.6, 25.3, 24.8, 24.6, 23.1, 22.5, and 20.8. Okay, you go back to, let me clear this now. You go back to stat, go to calc, blend reg, just hit enter a few times to get down here. There you go. So my equation is going to be negative 0.152x plus 40.91. If I go back to the PDF, there we go. So that should make sense because I deliberately made my y-intercept 41.9, so the linear intercept is pretty close to that. And this should be negative because oscillator of slope goes down as time passes, right? And what this tells me is that how much is slope decline per year in this period? Negative 0.52. So you say drops by 0.52% per year, because that's what it tells us. So expect 0.5% to drop. Now, what percent of the observed variation in percent of adults who smoke can be explained by the linear change over time? Okay, what percent cannot be explained? Okay, this is a little tricky, this question, but it's not that hard. What you have to do is you have to consider R squared. R squared is what you do to explain what percentage of variation can be explained by the change in time. So to find R, what you do, let me clear some, I'll undo it. You have to go to VARs, stats, because we're in a stats class, that makes sense. EQ, because we're doing an equation. Oops. And then obviously number 7. But you want to square that, so you get 0.969. Hey, Ashley. So what you do is you say, so R squared is 0.969. So what this means, 96.9% of the change of adults who smoke can be explained by the change in year. So that's what R squared tells us. It tells us what percent can be explained. So basically, most of the change in smokers can be explained by the change year, because as time passes, people are less likely to smoke. Why? Why do you think? Why do you think? I mean, like 1965. So it's probably when my dad was probably 21 years old. Time he's actually still in the Middle East. That my mom was, I think, 20. My in-laws were also around the same age. And then, of course, as time passes, but I never recall seeing my parents ever smoking cigarettes. I don't think they did. My in-laws, they said they used to smoke, and then when they had kids around the early 80s, they stopped smoking. So why do you think that dropped? What are some reasons? Well, what stories does data tell us?
People got more educated and like
Okay.
like the facts.
Yeah, because back then, actually, it's funny because there's some commercials that the smoking was good for you. Like it actually helped clear up your sinus, like menthol cigarettes. You know, that's just kind of crazy to think. Well, what are you gonna say, Luke?
And also like different devices, like nicotine devices.
Yeah, so vaping actually is not a new thing. That's been around for a while. It's just that the vaping's become more discreet. And of course, you had Juul that obviously we got put in the paper in the Atlantic. And there's a picture of the building last year. It's unfortunate, but because I mean, they're toiling a lot with the schools but there are actually Sacred Heart people who are heavy investors of the vaping device, which is unfortunate, but you know, it's just capitalism, right? But yeah. Also, the fact that people, oh, go ahead.
Yeah.
The Atlantic is it's like a left, like a liberal type of periodical that will share a story. Like, they write create 20-page articles. Like they've written stuff about like for example when all the mental health stuff was going on, you know, it's still going on, but they kind of wrote about that. Like, why is in the Bay Area we see a lot of mental health issues. They also wrote something about vaping, how vaping's become very prevalent. In the Bay Area, in the Peninsula schools, and then on the cover they had a picture of the main building, like a caricature of it. Wait, some kid what? Yeah, and one of my former students, his dad was a big executive for Juul. So yeah, it's just unfortunate that, you know. But anyway, yes, I think that could help. Also, laws, right? Think about legality. I remember when I was in the 80s, when I was a little kid, we'd go to a restaurant. The restaurant would always ask you, smoking or not. Like California, like you actually walk into a restaurant. I kid you not. I worked in restaurants in high school, and they changed a lot, I think, right when I was in 10th or 11th grade. So when I was your guys' age, the laws changed. So we'd have like maybe 2 rows of booths, and this row would be the smoking section. So this would be non-smoking. Of course, the non-smokers are from the far corner to get them away from the smokers, right? But when you're really busy, it's the only table you got a non-smoker. It kind of defeats the purpose. You're non-smoker, you're sitting literally right next to the two smoking activities, right? So the laws changed where now you can have it. And also they got worse, well, not worse, but like more strict, where you can't smoke within 30 feet of the building. I remember going to a 49ers game back around this time at Cal State, like people will leave their seats during halftime. People will be smoking cigarettes out in the concourse area. You can't do it anymore now. Like the police will actually have to leave. Actually, I was at the Giants game against the Dodgers, pure smoking everywhere, but not the cigarettes, but the other kind of stuff. They brought the cops too. So, but you know, anyway. Also, that's the other thing too. Like marijuana's become legal, right? So people say, you know what? Why smoke cigarettes? And also, cigarettes is expensive too. They've got more pricey, right? They've added more taxes. So there are a lot of reasons why. So it's just interesting when you start sharing the stories why you start seeing this. So it kind of makes sense. If we look at Part D now, one of the government's national health objectives was to reduce smoking to no more than 12% of adults. Okay, so you want to get to 12% adults. Use regression to predict the percent of adults who smoked in 2010. Does it appear the objective was met? Okay, that's kind of cool. So all you do, 2010 is going to be how many years after 1965? It's going to be 45 years after 1965, right? That's 45 years for X. So we plug in 45 into our formula, which I foolishly, I think it was like -0.52 X plus 40.91, right? So I plug in 45 into that formula. So 45 times, 45 times negative point, actually the calculus is going to bug out when we do this. 45 times negative 0.52 plus 40.91. So it looks like it doesn't happen until, so we get down to 17.5%. So we're probably not going to meet our goal of getting smoking down to 12% by year 2010. So anyway, another thing that you guys probably don't know. Again, the restaurant I used to work at when I was in high school. It's actually still there. It's now a different restaurant, but around the time of the 90s, we used to have vending machines for cigarettes. Yeah, it's like this old school, like you put like, you know, dollar bill coins in, and there's a little knob you turn and cigarettes would come out. And so that's kind of a problem because then your miner could totally just do that, right?
Wait, yeah.
I mean, yeah, just saying. So yeah, it's so all that, a lot of things that got put in place, and now alcohol beverage control, like they kind of handle an ATF, they handle all that stuff. Yeah, they actually have an encourage people go to, like, liquor stores and to see if somebody's actually selling cigarettes to a minor. So I mean, now we're more worried about vaping. That's kind of the bigger thing. But and again, use regression to predict the data value outside and then max value. That's called extrapolation. So extrapolate means you go beyond what the line could do, beyond what the data, but you kind of hope it will make sense. Here's the thing why it would not make sense though, because let's talk about the year 20, let's see, right now it's 2021. I'll be 44 actually next week. So yeah, thanks. My daughter's birthday was last week. So actually, let's say when my kids are like in their 30s, right? Because my daughter's 2, my son's 5, right? Well, he'll be 5 next week. But a lot of birthdays in our family. But let's say 30 years. So if I do 30 years from now, so that would be, see, right now it's 2021, so 2051. That would be 35, 86. Okay. 86 years from now. What if I plug that into the formula? So what would I get if I do that? 86 times negative 0.52 plus 40.9. Now you get a negative percentage? There's gonna be a negative number of people smoking. That's weird, right?
You see why extrapolate can be an issue at times, because there has to be kind of limit, or maybe it's not linear.
Maybe a better model would be exponential or logistic. We're not going to go down that path. That's, for if you do another stats class in college, you would do some modeling like that. But linear is not necessarily going to be making too much sense here after a certain time frame, right? So sometimes you have to kind of restrict the domain of what would make sense, because ultimately, because okay, maybe 30 years from now, I don't know how the world's going to look. Last year the world changed dramatically, right, compared to the 10 years prior. But who knows? But I'm guessing people will still be smoking cigarettes. I don't know. But it's a nasty habit, by the way. So nicotine's just not good for you. Anyway, this one I think we talked about. I think we talked about some of these here. I think we talked about. Did we talk about these 6 and 7? Okay, let's talk about 6 and 7 really fast. So, and then we'll talk about 8. Yeah, so let's go with 6, 7, 8, and then we'll play the game. So this is actually your way of going over the practice test. All right, a public opinion poll in Ohio wants to determine whether registered voters in the state approve of a measure to ban smoking. Okay, no smoking, ban smoking in all public areas. The register takes each county in the state and selects a random sample of 50 registered voters from the county, ask whether they approve or disapprove of the measure. This is an example of, okay, so they did for each county, and they got random sample 50 registered voters from the county. So California, for example, I think we have 52 or 56 counties, I can't remember. So if you think about it, if you have 56 counties in California, and then you take 50 registered voters, that's actually 2,500 voters in your sample, right? But you're guaranteeing that you get enough representation from each county. So how would you, what would we call this? Would it be a simple random sample, or would it be stratified? Stratified, you take different groups, exactly. This is a stratified random sample because you're doing it from each county. So again, let's take a look at California, right? Look at California. I don't know. I think we have 56 counties. I'm not 100% sure. So if you did 56 times 50, yikes, 56 times 50. I think it's 2,800 people. So you sample 2,800 people in the state of California, it's great. But if you just did 2,800 people randomly throughout the whole state, there's a good chance that you might have too much representation in LA County, for example, because LA County has a lot of people, or San Francisco County. you want to guarantee that I want to know how people are going to vote in, say, Stanislaus County or Sacramento County or Merced or Kings County, like, out there in the boonies, right? So you kind of want to get a good, sometimes you kind of want to get better representation. It's kind of like when I ask, like, people at the school, like, hey, what do you guys think about spring break? The seniors are going to say they love it because you guys usually do fun stuff during spring break, right? I don't know if you guys did something last year, but yeah. But if you ask a freshman, they probably wouldn't be as excited for spring break because they stay home. They don't do as much stuff. But I'd want to make sure I kind of ask all different groups, right? So some of the stratified random samples better. So you get representation from different groups that might have different opinions. For number 7, so select sample undergraduates in California, research sample, a simple random sample, 5 colleges from the state, and attempt to gather data about the chosen schools' entire undergraduate population. This is an example of. Yeah, go ahead. Yeah, cluster's a weird one. That's a cluster is like what you want to do is you kind of want to take, like, say you look the whole state of California, and you don't want to sample. Like actually, I think this is an example of a cluster. This would be a good example. Cluster, so, like, we know there's more than 5 colleges in the state of California, right? We have, like, I think almost like 30 or 40 Cal States, maybe more, I can't remember. We have a dozen or so, or I think 10 UCs, right? We have a bunch of private schools. So for me to sample all those schools would be really hard. So a cluster would be, I want to get, it's like a scaled down version. That's the best way to think. It's like a scaled down version of the whole population. So if I wanted to do it, so this is an example of a cluster random sampling. I'm not going to ask this because I haven't spent enough time talking about this with you guys, but it is cluster. Because what I want to do, because you want to get data about the chosen school's entire undergraduate populations. If I'm going to choose those 5 colleges, let me choose 1 private, maybe 1 UC, 1 Cal State. Try to keep it proportional, right? Maybe 1 like religious type school like Santa Clara or USD, and maybe another UC or another Cal State. So that would be a cluster where you're trying to kind of do a scaled down version of the whole population. So that's the cluster. Because it might be not feasible to survey all those colleges, because then you have to survey all the students too, right? So yeah, that would be an example of that. But I'm not going to ask that because that's I haven't really gone over that, guys. But this one that we can talk about, like how the wording of these questions could be weird. So I think we did part A. You have a police officer interviewing college freshmen asking if you've done a legal drug. Of course you're going to say no, right? So I think this would be a response bias, because you're going to be biased in how you respond because of the job duty of the person interviewing, right? So police officer, you're not going to say, yeah, of course I do this. No, you're going to lie, so you don't. So you're not going to get an actual accurate response. B, a survey about food and student capture is conducted by having forms available for customers to pick up at the cash register. Which, by the way, this might be a good project for you guys if you guys want to ask about food on campus. Might be a good one, because we're going to do a project after Thanksgiving break and about surveys, and this might be worthwhile for you guys to consider. So survey about food and student capture is conducted by having forms available for customers to pick up the cash register, a drop-box with forms available outside the cafeteria. I would say this is an example of convenience.
You also say volunteer.
Yes, absolutely. Because what if, like, you have to get to like a club meeting? Like, what if you're like, running the Iris Club or women's group or something else, or you have like a team meeting for water polo or football, or maybe you have to go study for a test, so you don't have time to fill this out. So, but for someone who's like, okay, they have a bunch of free periods after lunch, yeah, it might be convenient for them to fill it out, right? Or what if you didn't have a chance to go to lunch and someone picked up lunch for you, or you ordered DoorDash, you went to the corner of I'm not giving you guys ideas, but you guys were doing that. I know you guys were. Yeah, like by the corner of, I think, Park and Emily. I remember some people were doing that. That's hilarious. And we're still a close campus, but anyway. But yeah, the point I'm trying to make is that it's convenient if you're in that area, right? Involuntary, because what if you figure, I think the food's okay, I don't feel like filling it, but maybe you feel like you think the food sucks and you want to say why it sucks, right? So Then C, the sociologist wants to study the attitudes of American male college students toward marriage and husband-wife relations. Okay. She gives a questionnaire to 25 of the men enrolled in Sociology 101 at her college. All 25 complete and return the questionnaire. What do you think would be the issues with that one? I agree, undercover, absolutely, because you probably want to ask more people than just that, and not just in your sociology class, like those are people probably you know. You definitely would want to maybe have the university do the survey for you, because they have access to all the students' information, and maybe they randomly pick, maybe there's like 2,000 men to go to the college. Okay, maybe have it randomly pick 100 men, and then you send them an email saying, hey, you've been randomly chosen to fill out the survey, or you kind of like tell them, like, you got to come here and do the survey. So yeah, you're not really covering enough. I would agree. And then last one here, a survey on standardized tests and disclosures was sent out by email to the parents, sign up for the weekly newsletter. It asked the following: should elementary school age children have to pass high stakes tests in order to remain with their classmates? I would say it's probably a poorly worded question. I probably would say maybe convenience, perhaps. I don't know, because only people are signed up for the newsletter. Maybe you could say that's also convenience, but I would definitely say it's poorly worded, because then, like, you're putting fear in people's minds, like, oh crap, if my kid doesn't pass, they're not gonna remember the classmates, right? So I have to make sure. So I'd probably say no, right? Because that just seems crazy. So you should have worded, maybe said, do you support standardized tests? So keep it very simple. Don't add stuff to it. Sometimes less is more. So I'll make sure we have that discussion. Okay, cool. Any questions? No? Okay. So teams, you guys want to do the same teams?
Sure.
We'll do the same teams, okay. So here's how I'll do it. We're gonna have 3 categories. So I have these old practices I'm gonna put, but I don't have a PowerPoint, unfortunately. And actually, hold on, let me stop recording.